My name is Kent Mitchell. I'm the Director of Product Management at Zend, so that means I'm responsible for product requirements and strategy and direction. But today I'm going to pretend like I'm actually technical and talk about some things that are related to handling high availability PHP clusters in the cloud. First and foremost, I'm going to make some political statements that are probably controversial, but I think PHP is ultimately going to dominate the cloud. And my argument for that is, right now about a third of the web is already on PHP. So American Idol, New York Stock Exchange, Yahoo, lots of people are running Magento sites. So if you go out there and look right now, about a third of the websites that you hit on the web, and some of the really big names, are in PHP. Facebook is one of those that we were talking about, though Facebook's running a little bit of everything everywhere. But there, huge amount of stuff in the web. And a huge amount of the web is looking to go to the cloud for that ability to scale up. So, the question is interesting. If the economics are right, would Facebook have ever built hip-hop if they could have scaled up more easily? And the answer is probably, because given their problem, it's a significantly different one. But for a lot of people, if they could just scale up another server without having to wait 2 weeks to buy the thing from Dell, have it shipped, wait for their IT department to set it up, hopefully they did the same as they did last time, blah, 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 blah. So I think the web is going to actually get overrun by some of these PHP, or the cloud is going to get overrun by some of these web applications moving to the cloud. Now, there's about 4 million PHP developers. Clearly they're not all in this room. But there's about 4 million PHP developers, and that ranges from hobbyists to professional developers. One of the interesting things is Gartner recently published a study that showed that by the end of, I think, 2012, there'll probably be over 1.5 million what they call commercial PHP developers. So these are people who are making their living doing PHP in some way or another. And what we're seeing is adoption in the enterprise is much, much greater. And we're seeing a lot of people in the enterprise asking us about cloud. Sometimes it's private cloud, sometimes it's public cloud. It all depends on various things that are their tickle buttons. So a lot of times if people are very security conscious, they're worried about putting their data in the public cloud, and that's where private cloud comes in. The other thing about PHP that I think makes it really sort of work well in the cloud is it's the whole ecosystem. So it's not just PHP the language, but it's things like Zend Framework, which is a framework, open source framework for PHP services. It's things like Eclipse, the Eclipse PDT project, which is an open source PHP editor, lightweight IDE if you want to call it that. It's interesting, the Eclipse PDT project, because when we started it at Zend about 3 or 4 years ago, the Eclipse team was like, yeah, well, who's going to care about PHP, blah, blah, blah. Right now, other than Java, it's the #1 downloaded thing at Eclipse. PHP is the most popular language they have at Eclipse after Java. It's the most popular anything they have after the Java IDE itself. There's a set of tools around that, like Zen Studio. There's things like Dojo, XML, Ajax toolkits. There's different web servers. There's Apache IIS. There's databases like Oracle, IBM, DB2. All of these things have support for PHP, and then you surround that with a whole bunch of off-the-shelf applications that work pretty damn well and are free, like Drupal, Knowledge Tree, Magento, WordPress, Sugar CRM. So a lot of people can go out and grab things, and what we're seeing is people actually go grab these applications and use them as the foundation. At a keynote at Zen's conference yesterday, we actually had a presentation from the New York Stock Exchange talking about how they were able to use PHP and Drupal to basically bring up websites on a project that was basically several years into the development under Java, and they brought it up in PHP in a few months. And it was one of those things where they came out, they said, we're going to do it this way. People said it'll never work, and you can't use PHP at the New York Stock Exchange, and they basically built it, and it's all working, and they said, this is pretty good. We had another customer who was trying to bring up a mobile app, and he brought it up in basically 4 days using Drupal and tweaking it. So it was all very interesting stuff. So I think that ecosystem, the developers, and the fact that the web is already running PHP is going to drive that to the cloud. The other thing about it is PHP's architecture in general is perfect for the cloud. The greatest thing about PHP is it's pretty much, if you don't screw it up, linearly scalable. You can just add more servers to add more capacity. And if you're running them at maximum capacity, utilizing your CPUs, your memory, maximum number of PHP processes you can run, adding another server will pretty much scale up. That's because PHP is inherently stateless. So once it processes a request, pretty much throws everything away. The next request comes in, it'll do it. There's obviously downsides to being stateless, but linear scalability is definitely an upside. And so if you're looking for something to run in the cloud, you want something that's going to scale cleanly. If you try to scale a J2EE app server in the cloud, it's a little bit more complicated because they're trying to share sessions and session data and various other things across that cluster. Gets a little bit tricky at times. Also, PHP is deterministic from an execution standpoint. Basically, if you can get the process thread, it'll process the request, it'll return the response that frees the thread up for somebody else. Basically, all of its data gets thrown away. Everything pretty much works the same way every time. There's also database support. So right now, PHP is got support for pretty much any database you can think of at this point. And a lot of the database technologies have added stuff that helps that linear scalability. So for example, database side connection pooling. So you may not be aware of this, but Oracle and IBM DB2 have a capability that basically says, normally when you establish a connection to the database, that's the slowest thing you can possibly do. And what they've done is they've added connection pooling to the database so that, in fact, if you come in with the same credentials as last time, it'll reuse the connection at the database layer. So the thing that was really slow is now relatively quick. And so they did that in Java by having connection pools in the Java app servers because they could. But because PHP was stateless, and Oracle and IBM, and to some extent MySQL, wanted things to be fast, they were forced to put it in the database, which is probably really where the connection was slow in the first place. And so they essentially sped up the connection capabilities in the database. So that kind of support means that architecture is great for the cloud. The problem is, people can break anything. You can start with the coolest thing, like a cell phone, but if you use it for a hammer, it doesn't work very well. And what people do in the cloud that really screws stuff up is first they treat cloud instances like physical machines. So when it used to take you 2 weeks to buy a machine and maybe 6 weeks to get the approval to buy the machine and then 3 weeks to set it up and then it had to be put into the computer room and then you had to get the applications on it and it was like 2 months before you got the server, what'd you do? If you needed to deploy a second application, you'd kind of look at those servers and say, man, they're not very heavily loaded. Let me just throw another application on those servers. The problem with that is that when one of those applications starts to get thoroughly loaded and now is taking up those machines and now the other applications on it aren't being serviced, you've got to figure out how to move them off. You can't scale them up because if you just add another server, you're really scaling up stuff to handle load on one application that's not the other. And the whole idea behind the cloud is to get granular scalability. So we have a customer that we're dealing with. Strangely enough, they have websites for musical artists. Now, it might be a surprise to you, but websites for musical artists don't always have consistent traffic. For example, Michael Jackson's website wasn't actually all that popular or busy, even as famous as Michael Jackson was, until he died. And then the website was really busy. Lindsay Lohan's website wasn't all that busy until she got arrested again. And then it became really busy. And they were putting all of these websites on the same servers. And what they found was when this kind of thing would happen, we'd get denial of service issues on the other artists that were on those sites. And so they basically have been in the process of breaking these things down and putting them onto individual sites and not treating cloud instances like their machines. Scale them down to the size that you need to handle that at a minimal level. Scale up as you need, because you only get the economics in the cloud if you can scale down as well as scale up. It makes no sense to run an Amazon large instance if you don't really need that much memory and you don't really need that many cores. And quite honestly, PHP doesn't need that unless you're going to try to pump a tremendous amount of stuff through one server. Why? Run smaller instances that cost 9 cents a minute, 9 cents an hour, and run 3 of them rather than one massive instance. It's cheaper. And when you don't need all 3, you can scale it down. The other thing is, because PHP is linearly scalable, what you can do is pick the wrong database, or you can try to pick a centralized caching server like Memcache, and you can basically introduce a single point of failure. So we had a wonderful system that would allow us to scale out linearly. Now it's all going to one choke point. That one choke point can basically break the whole thing. If the memcache server goes down, my performance goes down, my caching's gone, everything's gone. So they introduce, single points of failure. They also introduce nonlinear scalability. So let's say that you even decide to put a memcache server in there and you decide to use proxies to make it basically, fault tolerant. Great. So how many servers do I add before I add a memcache server? With RightScale, you can take care of that. You could say, okay, for every 3 servers I add on the web server side, I'm going to vote to grow the memcache side. They could basically do stuff like that. But quite honestly, a lot of people, if you don't have something like RightScale to manage that for you, they don't pay attention to that and they wonder why their servers suddenly bog down because they basically introduced something that doesn't scale linearly. So you can take something like PHP that's designed really well to scale linearly and you can basically break it. So people start with something that looks like this and then their caching server gets overloaded and their database server gets overloaded and basically they've got this wonderful system that now doesn't scale. It's not highly available. So the idea behind Zend and Zend's products is Zend is the PHP company. So we are basically the commercial arm of PHP. Much like in the early days, Red Hat was the commercial arm for Linux. Obviously, lots of other people jumped in there. Oracle, CentOS, various other people. So there are a number of commercial arms. Quite honestly, we're still really the only commercial arm for PHP out there. Zend tries to cover the whole life cycle. So on the development side, we have Zend Framework, which is an open source framework. Clearly, at this point, the most popular PHP framework out there. Over 10 million downloads since it was launched. If you look at the downloads and the traffic associated with it with any other PHP framework, it's probably an order of magnitude more. We launched the new version this week, and I'm sure Boaz, who's sitting back here in the other white shirt, could tell you that our site has probably gotten much, much busier when they launched the new version. Basically, a lot of people going to get it. Zen Studio is our IDE product. It's built on top of Eclipse PDT, the open source product. Adds a bunch of nice features. It's integrated with Zen Framework. It's integrated with Zen Server. It has a lot of really cool stuff like Ajax support. So if you're doing Ajax and PHP together, you can debug from the Ajax into the PHP and then back out into the Ajax in one continuous debug session. A lot of nice features. But the thing we're really talking about today for high availability clusters is the combination of Zend Server and Zend Server Cluster Manager. So Zend Server is basically the server that runs the PHP that faces your customers. It's basically a PHP stack, so think of it as LAMP, but it adds a lot of nice features. So it adds a monitoring system that will keep track of what's going on in the PHP system and report back PHP level information to you. It has code tracing. Think of that like a black box recorder in an airplane that's constantly monitoring what's going on in the system, and should something bad happen, you still have data to diagnose the problem. So we've all been there. Somebody calls up and says, your website was slow last Tuesday at 4 o'clock. Great. Fantastic. How do I diagnose that? Well, I go wade through some Apache and PHP logs with the 27 million other pieces of data that are in there looking for something significant, and I'll show you how Zend Server makes that all a lot simpler. So it's basically the production-ready PHP stack. It has capabilities that we'll talk about in a minute. Zend Server Cluster Manager is the thing that manages a cluster of those servers. It centralizes the configuration of those servers. It centralizes the management of those servers. It centralizes the monitoring of those servers. And it basically also will provide a way to deploy applications across the cluster as well. So we'll talk about all of this a little bit. So why is Zend Server the HA PHP solution? For one thing, it provides completely transparent session failover. So if you're writing a PHP application, it uses PHP sessions to store stuff like shopping cart information, other kinds of stuff for your session. Without changing a line of code, you can basically link that completely HA. And within the cluster, Zend Server will replicate that session across another machine as a backup, and should the primary machine fail, it'll automatically fail over to the backup. You don't have to change anything. It's completely transparent. So it's also fully distributed peer-to-peer. So even if the Zend Server Cluster Manager happens to go down, the cluster is still coordinating the session activity. So you can't scale up while the cluster manager is down, you can't scale down, but your session, your PHP cluster will continue to service the customers. We also provide distributed caching. One of the things that's kind of interesting that people try to do with caching, and makes no sense at all if you stop to think about it, is they try to make sure that the cache is completely coherent across the servers. So they'll say, oh, I'm going to use memcache for my caching, because then if server A writes into memcache, it'll store it. If server B writes into memcache or reads from memcache, it'll get the most current data. Great, I'm glad you're really worrying about that, because you've already got the world's largest race condition ever, which is you're looking at a browser. So I just pulled up the thing for the cool Zend PHP elephant. If you haven't seen them, you can go over to the Zen booths. We'll let you in. You can try to get one of the fuzzy blue elephants. In the meantime, while I'm looking at my web browser for minutes, trying to decide if I want the large elephant or the small elephant, Yuri comes along and says, hey, I'm going to buy the last small elephant there is. He buys it. Okay, great. The cache is updated, but I'm still looking at a browser that's 10 minutes old. I hit purchase. It has to go back and figure out that it's not really there anymore anyway. It has to give me an error. So you've got race conditions going on all over the place, but you're worried about caching to make sure that this server is exactly in sync with that server. It's crazy. It's a waste of time. What's better is to figure out what's the window that you can live with as an acceptable race condition, and distribute your cache across all the servers so that if any one of them fails, it fails, but the rest of them keep working, and you don't have a single point of failure. And a classic example is we had a customer who said, look, my website gets 6,000 hits a minute, and every single person that hits that website gets a different special offer. And we said, great, how many special offers are there? 10. And he said, I can't cache because everybody has to hit the website, has to get a different special offer. I said, really? He goes, yeah. I said, okay, so let's say we set the cache for 10 seconds. He goes, yeah, in that 10 seconds, 1,000 people hit the website, and they'll all get the same offer. And I said, so? And he said, what do you mean, so? I said, they don't know that. I said, in the next 10 seconds, the next 10,000 people will get a different special offer. And they don't know that either. And I don't think anybody's going to hit refresh 10 times in the 10-second period and realize they're getting the same special offer. And if they do, they'll eventually get a different one. But the net effect was they could reduce the load on their site 1,000 to 1 by using some PHP-aware page caching and a really short timeout on the cache of 10 seconds. And they still reduced their load by 1,000, by a factor of 1,000. Okay, technically 999, but who's checking? And fundamentally, people get all hung up about caching and caching currency and whatever. And what you really should be doing is worrying about cache invalidation. At the very most, you need to invalidate the cache across the cluster. You don't need to worry about consistency of caching, because you're never going to get it anyway, because the browser is disconnected. So instead of worrying about and cohesively trying to do everything, try to get the single points of failure out of your system. Try to get the things that don't scale linearly out of your system. And so you've got a system here that takes PHP and leaves it the way it was when it appeared, which was something that would scale linearly, by adding a transparent session cluster mechanism that doesn't slow down with the size of the cluster. You've got a caching mechanism that doesn't rely on any centralization of the cache or any central server. You've got a PHP-aware cache that, again, doesn't rely on any centralized mechanism. Now, Zen's Cloud Platform is a whole series of pieces of functionality, and I'm going to kind of walk down for this one a little bit because it's easier if I point. So this is sort of Zen Server right here, okay? And this is basically Zen Framework. So Zen Framework is a whole series of programmatic services like authentication, security, support for rich internet applications, model view controller layer, support for mobile, support for data access. And it does this in a way that's transparent in many cases to the underlying mechanism. So you can swap out data providers like Oracle and MySQL, and pretty much this will work. You can swap in different security providers like LDAP or Active Directory or Kerberos or anything, and the code will be the same. Zend Server provides a set of runtime layers, and these are things that are generally transparent to the application. So session clustering that just happens transparently. Management of the configuration of the PHP settings is something that the application generally doesn't worry about. Application monitoring is constantly watching your system in the background for slow responses, slow database queries, function errors, various other things, and recording all this information and unifying it back into one central place with the cluster manager. And then you've got an enterprise-grade PHP. We take the PHP, we take all the extensions, we compile them together, we test them all together, we test them with all the right libraries. On the top layer, there's programmatic interfaces for PHP. There's an initiative that Zen had called Simple Cloud. We launched it about a year ago with Amazon, with Rackspace, with IBM, with Microsoft, to create technically a language independent set of APIs, a definition of a set of APIs that can be used to access basic cloud services like storage and other things independent of the provider, so that you could write an application that would run on Amazon or the IBM cloud or Azure independent. Okay? Now it's supposed to be language independent as well. So far, exactly one company has stepped up to the plate to build the API. It'd be us. IBM, who said they were going to build a Java version, never got around to it. They maybe will eventually. But there are other cloud services out there that you may want to take advantage of, and those cloud services might be cloud dependent. Down here, okay, is where RightScale comes in. You need RightScale to handle provisioning, scaling, monitoring at the level, making sure servers aren't dying on you, various other things that RightScale is very, very good at. Zen doesn't want to do this. We don't know how to do this. We won't even claim to know how to do this. What we know is PHP. We know PHP editors and various other things. So the cloud infrastructure is below that, or above it, depending on, or next to it. I'm not really sure how to ever draw these diagrams, but fundamentally there's cloud infrastructure over here, and there's cloud services over here. So what you've got is a platform that allows you to build applications, stick them in this cloud, and keep them relatively transparent with respect to the cloud you're running in. And we're ultimately going to try to create essentially a PHP platform as a service. Now, we're a technology provider. So we're not going to actually provide a cloud platform like Heroku does for Rails. We're going to provide a technology to let people use RightScale to create their own platform. So if you want to use Memcache because you think I'm an idiot and I don't know what I'm talking about with Memcache, knock yourself out. RightScale has templates that'll bring up Memcache servers. They know how to scale them. They know how to deal with that. If you think your platform needs to have a Memcache server, go for it. We'll provide templates out of the box. They'll be tweakable. We'll do the same thing for VMware. We'll do the same thing for other cloud providers, and basically provide you with a consistent UI for that and a consistent way of working with that. It's up to you to decide how much you want to tweak or customize that, because one of the things about platform as a service that doesn't work for people is one size does not fit all. I'm absolutely certain that my clothes don't fit some of the people in this room, and vice versa. Okay? Same thing with platform as a service. You need to be able to tweak it. It's okay to have a platform as a service as long as it's your platform. Then you get the consistency where the developers can get the platform they're used to, the QA people get the platform that's similar to the production platform, and they all have the ability to use the same thing. The solution that we launched with RightScale, what was it, Yuri, about a month and a half ago, something like that, for their development and test solution. It's a solution pack from RightScale. It utilizes Zend Server as its PHP solution, and it allows a customer to set up essentially their development and test platform as a set of RightScale deployments. And basically the developer can go in and go, okay, give me an all-in-one developer system so I can just do some simple functional testing. QA can go in and say, okay, give me a load balanced cluster because I've got to do scalability testing. And you can basically define as an administrator those configurations, and as an end user they just pick from a Chinese menu of what they want. Boom, I want one of these. And well, I guess it's not a Chinese menu. They pick from a menu. I say I want one of these. Portal. Okay, from a portal. There you go. Self-provisioning. Self-provisioning portal. Didn't get the language quite right. Thanks. So the idea behind this is to basically use RightScale Cloud Management and the Zend Server Cluster Manager to create an array of Zend servers that will scale out linearly with a MySQL database and the master-slave kind of configuration with replication and auto failover. And the MySQL database is something that RightScale has some scripts for to basically auto failover when something happens, promote one of the slaves to a master, maybe create some new slaves. And in fact, in the fully infoliated version of this, what you need is when RightScale changes the MySQL configuration, it can tell Zen Server Cluster Manager. Zen Server Cluster Manager can then tell all the servers in the cluster, hey, don't talk to this machine anymore, talk to that machine. And there's other things that can be done. So all of these different pieces, parts, Zend has their expertise in PHP, RightScale has their expertise in cloud management, database vendors will have their expertise in database, and they all have to learn to do a slow waltz together. Now how 3 or 4 vendors do a waltz at the same time will probably look a little strange, but we'll hopefully get all that smoothed out. Between us and RightScale, I think we've got a pretty good solution going already.